Hi everyone, me again. Right, this is update 13. Unlucky for some. Right, been modifying the Gen 3. Now basically the overall name of the project is to feed the back EMF back to the source. What can I say? I think I've done it. How have I done it is a good question. Right, I've been playing with optocouplers, which I mentioned in my last video. Basically, how I've got it set up is that when the drive coil pulses, the optocoupler that I've got connected between the capacitor storing the back EMF, it connects it to the voltage rail. Now this has actually caused some well, quite an interesting revelation, in that some of the more advanced bedini developers are going to like this. So let's take a look. Apologies for it being a tad dark. Oh, blooming heck, it's dark. Oh dear, oh dear, 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 dear. Right. I've got that running quite nicely on 22 milliamps. Right, remember, this is without the generator circuits. Right, it's running about as fast as it was. Right. Now, you can see I've got crop clips all over the place, so apologies. Right, that's the back EMF capacitor. I'm not going to get my finger too close. Right, and if I can not cause shadows, see where the yellow cable goes, that black thing right in the centre? That's my optocoupler. Right, so that's the voltage that's in there at the moment. Just under 20 volts, more or less. So, here's the question. What's actually happening? Okie dokie. Right. The back EMF is charging the capacitor. Right. Now, it's charging the capacitor to 20 volts, as you've just seen. Well, just under. Okay. Now, when the optocoupler opens, that gets dumped onto the positive rail. Now, the interesting thing is that actually increases the voltage on the positive rail. So much so that a surge goes through the drive coil. So it ends up pulsing with a higher voltage than what goes in. Now obviously the capacitor itself does not hold enough charge to allow the drive coil to pulse continuously at that voltage, so it drops back down to 12 volts. Right. But it's dumping that voltage in right at the beginning of the pulse, which means that's where it's getting the maximum amount of force on the magnets right at the start of the pulse, which means that I've been able to tune down my bedini by maintaining its speed, which is rather interesting, which means instead of drawing at that speed probably 35 to 40 milliamps, it's now only drawing about 22, which gets me even closer to the objective. The overall objective is quite simple: to make a device that is powered by itself. Sounds simple. It isn't. But there we go. Now, one of the things I've kind of abandoned at the moment with my current coil is trying to isolate the trigger coil from the transistors that cause the pulse. So I tried using an optocoupler there, which unfortunately, the problem was that the trigger coil cannot sustain the amount of current required to drive the optocoupler, the optical transistor, whatever you want to call it, same difference. Because basically, as I think I explained on my last video, the optocoupler is an LED on one side and an optical transistor on the other side. So quite literally it needs, I think the spec said something like 50 milliamps at it's like 2.5 volts, 3 volts, something like that, which unfortunately is far too much for my trigger coil, and it produces far too much lens effect at that current. So for the time being, that one's been abandoned. Maybe on a bigger coil. Even some of you guys using bigger coils can experiment with optocouplers to drive your bedini. That way, if you use an optocoupler, there's no electrical connection from your trigger coil to your main battery, which means you can then use something like a voltage doubling rectifier and basically use the trigger coil the way that it is as a generator coil. The only thing is you're going to get increased lens the more you draw from it, but those of you with bigger systems can probably get away with it, to be honest. So that's an interesting revelation for people. Just in case you want to see the circuit, here goes nothing. Right, that's how I was originally going to drive the optocoupler for the trigger coil, like that, and then feed it into doubling rectifier. So this bit's been abandoned and it's just a normal connection for bedini. This bit here, with a 20 kilo ohm variable resistor, goes into that optocoupler for the back EMF, which is what we like. And yes, I spent about 5 minutes neatening the circuit up so it's a little bit easier to understand. So that's that one. Another benefit to the bedini system there for you. Anyone playing with the optocoupler to discharge the back EMF onto the power rails, be aware that if you open the pot up too much, then you'll short out the back EMF. Right, so there's, as I showed you in the last video, you've got that little sort of tail after the pulse, so you really need to be careful of that. But anyone playing with it will quickly realise what's going on anyway, hopefully. So, any questions, comments, as always, feel free. Talk to you later.